parentheses. All right, listen up, you people. Okay, now we are doing triangle angle bisector theorem. Now for these problems right here, you guys have a ruler, okay? And so you have a ruler and you have, what else did I give you guys? You guys got the practice for that and just about everything. So you got everything you need for this. So I'm going to go through and I'm going to do a full example and showing you why this works. And that's the main point that we're trying to get at. So I'm going to show you why this works. Oh, here it is. I have my ruler. This is the one ruler to rule them all. Yes, I went there. All right, so right here. Now, for this right here, you could use side splitter theorem to prove what we have right here. So triangle angle bisector theorem. If a ray, now you guys, what's a ray? Has one endpoint and goes on forever. Okay, good. Bisects. Class, what does bisect mean? Cut in half. Cut into two equal parts. Very good. Hey, you're on top of things. Okay. An angle of a triangle, then it divides the angle into segments that are proportional to the other two sides of the triangle. Okay. Now, as a proof, I'm going to take my ruler and I'm going to extend my lines. See this ray right here? I'm going to extend those lines. So I'm extending their lines. Now, I'm also going to draw a parallel line at B. So, parallel means going in the same direction, right? Yeah. Okay, never goes closer, never gets farther apart. Same width. Okay, so it's going to be parallel to this line right here. So, I'm going to draw a parallel line. So, do your best to try and draw it parallel, because we didn't do the constructions unit this year. Oh man, come on, autofocus, you got this. All right, so let's take a look, and I'm gonna draw a parallel line right here, extend it nice right here. All right, let's see. Okay, so now for that, so now I'm also going to extend one more line. I'm going to extend CA. So I'm going to extend this one right here. So when I'm done with that, it is going to intersect my line that I have over here. Come on. You got this. You can do it. This is going to make people nauseous if they're trying to watch this video while they're driving. Oh my goodness.
Why would they watch it? Yeah.
Now, so, I'm just saying if you guys are even paying attention. All right, so for right here, we've actually made another triangle out of this right here. Okay, so I'm going to go through and do a couple things with this. So if I did this correctly, these lines are parallel. So I'm going to draw a little doohickey right here. So here's the marking, the arrow, to show that this one is parallel to this one right here. Okay? And because I've done that, I've also done a couple things. Now, this is going to be a transversal in between these two parallel lines. Okay, I have a transversal in between these two parallel lines. So because of that, there's a couple things I'm going to know. This one is also going to be a transversal between my parallel lines. So I have this one here, and I have this one right here. Now, I know that this one right here, okay, since these are parallel, so I have my parallel line right here, this one, which I will mark with a red, number 1, and this over here are going to be congruent. Now, class, Can you guys tell me why these two here are going to be congruent? Corresponding. Excellent. These are going to be corresponding angles here. There's a whole bunch of mess with a bunch of lines going different ways, but yes, these ones here will be corresponding. That's important. Now, the next thing I'm going to do is I'm going to identify another piece of that. I have a colored pencil here somewhere. And it just so happened to be, oh, there's a brown one. Hopefully that'll work. Okay, so now for this, I know that if this is a transversal here, in between these two parallel lines, this one right here, that I'm going to do in brown, and this one right here will also be congruent. Why are these two right here going to be congruent? Very good. Alternate interior angles. So these are alternate interior angles here. So I have these all going together.
Are angle 1 and 2 different?
1 and 2 are congruent because that's what we started off with here. We're starting off with that this right here, 1 and 2, are going to be congruent because this is bisecting my angle A. So I have these bisected here now. So now because of that, let's take a look. So because of that, I have a whole lot here. So I have that these two are going to be the same. This one is congruent to this one, right? This one is congruent to this one, right? These two are congruent to each other because we started off with bisecting this angle. So that makes this triangle over here a, what type of triangle? Base angles are congruent here.
Angle, side angle.
Close. Close.
Side angle, side.
No, this one right here. If the two angles on the bottom are the same, it's going to be isosceles. I know you guys are thinking like current. I was talking about stuff we did like first semester. So first semester stuff. So yes, it's going to be isosceles because if this and this are congruent, that means that this side and this side are also congruent. So if the base angles are congruent, then the two sides are congruent. So I'm going to state that this one right here is going to be congruent to this one right here because these whole thing right here makes an isosceles triangle. Now, let's take a look, and I'm going to start filling in some that I have here. Okay, so I've already gone through and done that, so let's fill in what we have here to go with my proof. Okay, it says given triangle ABC, that's what I had right here. AD bisects CAB. So AD cut this one into 2 equal parts. CAB, this cut into 2 equal parts. So we drew a line. So B, and then up here, we're going to draw a, so this is one of the lines that we drew, and I'm going to put a point over here at the end. I'm going to call this one here E, because it was asking us to do this right here in this step, right here. So extend, okay, draw BE and AD. So AD was this line that was parallel. BE is this line right here. So we drew those. So we extended those lines. Okay. Extend CA to BE at point F. CA connects BE. So that makes this one right here point F. So I have that one as point F now. So we're going through and labeling everything that we said. So side splitter theorem, CD. Okay, CD is actually going to be right here over DB, this one right here. So we're talking about just the bottom of this right here. CD over DB is going to be equal to CA, which goes along with this because CD is from here. So if we split this into two separate triangles here. We're going to have this piece right here, and then this one over here. So CD goes with CA, and then DB, and here. So as we set it up, CD is on top, DB is on bottom, CA is on top, and AF is on bottom. So from this one we get, it goes to here. This is my whole ratio, but there's a reason why I had to start off with showing that these two angles are congruent. So when these two angles are congruent here, we make an isosceles triangle, and so this piece right here is going to be congruent to this piece right here. This is not going to be included in your practice problems. You're not going to have to extend your lines. You just need to know that because of all that I did over here, this piece is going to be the same as this. That's what I was trying to do with this. So it's going to be the same here. Okay?
Wait, that's why you didn't say AB?
Huh?
Is that why you didn't say AB? You said AF?
Yeah, it didn't say AB, right? It said AF right here. This is the theorem. This is congruent to this. Because you're not going to draw and extend your lines every time you try and do one of these problems. You just know that instead of AF, you're going to write AB, which is going to be this side of the triangle here. So it'll make a little bit more sense when we actually go and actually do some of the practice problems, that you don't have to draw them. Okay? So let's take a look. Then angle 1, okay, so I'm sorry, right here, I skipped a spot. Label AFB. AFB as 3. So I'm going to put a 3 right there. There's angle 3. ABF, ABF as angle 4. So I'm going to put a 4 there. Angle 1 is congruent to angle 2 by definition. So angle 1 was congruent to angle 2 by what definition? Why did we say these two are congruent? Very good. Bisect. That was actually given at the beginning, right? So this is what I'm going to put in. I'm going to put in my bisect. Angle 1 is congruent to angle 3. 1 is congruent to angle 3 because they are, what do we say these ones are? Corresponding. Very good. 1 and 3 were corresponding. Two and four are congruent because they are, very good, alternate interior. So they're alternate interior angles. If 1 is congruent to 2, 1 is congruent to 2, and 1 is congruent to 3, then 2 is congruent to 3 by the transitive. Very good. Transitive property. So I had the transitive property. So angle 3 is congruent to angle 4. 3 is congruent to angle 4 by substitution, and then BAF. Let's take a look. BAF, which I had over here, this is the one that I drew, okay, is a blank triangle. Isosceles. I think there's like an I in here. There's another I somewhere there. Okay. It looks close enough. So it's isosceles. Okay. Therefore, AB. AB is congruent to AF. So we did all that just to say that these two are going to go together. This is the proof. This is the mathematical reasoning. Why? Now, do you need to know why every single time? No. You just need to do. So let's take a look at this one right here. We did a whole bunch of substitution, blah, 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 blah. So this is the piece that I'm trying to get out of it. Now, find the value of x. So if you notice, right here, I have x right there, right? Okay, so we're going to find the value of x. So for this one right here, we have it set up so S is the one being bisected, right? Yes, S is the one that's being bisected. So if I set it up like this, I have everything already there for me. Okay? Has it there for me already. PS. What am I going to put for PS? Come on, you guys. PS. PS. What value is PS? X. Very good. X over SR. What is SR? Just so you know, it kind of cut off on the sheet right here. It's going to be 6 equals. It says PQ. What is PQ? 8 over RQ. 5. Okay, good. So now that I have that, what am I going to do from here? Multiply cross products, right? So X over 6 equals 8 over 5. So do I cross products? I get X times 5 is 5X equals 6 times 8. Thought I heard it. Loud and clear. 48. So I get 48, right? So what am I going to do to both sides? Divide by 5. Let's do that. So X gives me something. So it's going to be, what does that symbol right there mean? About, approximately, right? So X is going to be approximately what?
9.6.
Very good. 9.6. Approximately. Okay, not too bad. This one had everything set up for us though, right? Okay, let's use the same information to see if we could actually set up the next one. This next one's a little bit more complicated. So let's take a look how I did this one right here. So I started off with X over 6. Here's my bisected angle, right? These are the two legs that are attached to my bisected angle, right? So I started with this over this. Yeah? Okay. Now let's take a look at the next problem. So on the next problem, I'm still considering this part right here. So my bisected angle is down here, isn't it? Okay. So how am I going to set up my first part of my fraction? Come on, you guys. You want what? 28 over 20? That'll work. Could I also do 20 over 28?
Yeah.
Yes. Both will give you the same thing as long as you set up the second part correctly. So I'm going to go 28 over 20. Equals. Now, let's take a look. On the previous problem, I went X over 6 because this is my bisected angle, and these are the legs attached to that. So it was X over 6. And the next part was 8 over 5. Now, if you notice, part of this triangle over here was one of them, right? So this one, so the X was on top of my fraction. So over here, the 8 went on top because that was all the same part over here. Now let's do the same thing over here. If I have 28 over 20, what goes on top of my second side? 7, very good, over X. 7 over X. Make sense? Okay, so given that much information right there, let's go ahead and set up my cross products. So 28 times X is 28X equals 140. Divide both sides by 28. X is what? 5.
Yeah.
Very good. Just making sure. So if I say things with the question mark, you know, people are like, what? Okay, anyway. So if I wanted to solve for y, Chris, what would I do to solve for y?
Isn't the same thing. Plug in X.
Plug in x. So x is 5. So what is y? So y would be 7 plus 5. Is that what you're saying?
Yeah.
That's what I'm actually trying to get you to say. But okay. So y is very good. Is that so bad?
Not when you put it that way.
Okay. So, yes, I put it that way, and now Chris is going to put it the same way.
What?
So please take out your practice.
What? I'm lost, bro.
Nope, not yet. This is still on the video. Still recording this. So no pressure. No pressure. Everyone's watching you right now.
Oh,
I'm not going to say your last name either, so,
that's fine.
Like
okay.
one person's watching.
Okay. 2.
Okay.
Okay, so Chris.
Yo.
Okay.
Oh, wait. Oh, no.
How am I going to set up this problem right here?
Well, you gotta put numbers in my order, that's for sure.
Very good. So which numbers do I start with?
I guess it's 12.
Which one?
12.
12 and?
12 and 10.
Very good. 12 and 10. Why? Because someone said it, or?
Yeah.
Okay. Do you notice? We start here. This is my angle that's bisected, right?
Yes.
My two legs attached to that angle are 12 and 10. That's what I start with, okay? 12 over 10 equals. Now, this next part is crucial because depends on how you set up your first one, your second one has to go with that one. So, Chris, how would I set up the second part without anyone else, saying it? Because I know you know this.
I guess so, but alright. X over 5.
Excellent. Very good. X over 5. There we go. So 12. Yep. Same triangle here. 10 and 5. Same triangle. Very good. Okay. You go through, solve for x. There it is. You got this?
I have a question.
Yes.
Okay, so say if you didn't want to do it that way, and you did the Pythagorean theorem, so 12...
Pythagorean theorem only works with right triangles. Are these right triangles? That's why. Okay. There is another formula. You're going to learn it when you take trigonometry in a couple years. It's actually it's kind of like the Pythagorean theorem, but it's actually broken up for non-right triangles. It's like law of sines and law of cosines.
So then, like, say the middle one, the length, the full length is 10.
This one right here, yes.
Yeah. So those two are always going to add up to be...
This and this will add up to be 10.
Okay.
Okay, so now, if you think about it, for this side right here, this is actually a very good question. How would I figure out what I would write for this? Okay, now, before you answer that, I want to look at this one right below. Okay, because the same mathematical steps happen here. How would I figure out, can I figure out what's missing there?
Yes.
What would you do? Now, you have to actually think about it mathematically of what would I do.
36 minus 15.
It would be 36 minus 15 would give me this piece right here, right? Okay. Exact same steps. Because we're including a variable in this, that's the reason why you would just have to have the same steps. So, this piece right here, what would I write? Come on, Anna, you got this. This was your question. Okay, let's do this again, right? To get this piece right here, just this little piece right there.
Wait, 10 minus x? Or is that what's that mean?
Yeah, you would put 10 minus x, right?
Oh.
That's correct. So for this piece right here, to figure out what this is, because this is a variable, this is an unknown, you would have for this piece, it would be a 10 minus x, wouldn't it?
Yeah.
So that's what you're going to write. But over here, you would do 36 minus 15, but you can put those together because neither of them are variables. So you actually do get a number here. This one, you get an expression, you get 10 minus x. Does that make sense?
Yeah.
Okay, are we good? All right, so hopefully someone's watching this. They'll like and subscribe.